states that matter can't be created or destroyed, only what?
Rearranged.
Rearranged. That's actually my exact word, you saw it. What are words that describe rearranged?
Mixed up.
Raise your hands so I can hear you. You could change its state. That's a pretty good way of explaining it. Change its state, I'll write that. Okay, that's not working too well. What else?
Shuffling it.
Shuffling it, I like it. Never heard that one, but I'll write it. Shuffle. What else? Transform. What else? I'm writing all these words. Why? Because they're going to appear in so many different ways. I want you to become familiar with all the ways. Transferred. Okay?
Substituted.
Okay, that's it. You get it? Yes. All right. On Earth, matter is what? Everybody saw it? Closed. What does that mean exactly?
Like nothing.
So he doesn't leave.
It doesn't leave. Whatever is here is going to be passed on into one form or another through a cycle, except when? If you, good. You see my picture?
Unless it goes into the
Space or out of Earth, or we bring it back. We either take it out or bring it back. And we've done that, right? We've brought in matter from other planets and we've taken our matter and built space stations out of this Earth. Yes, and we have matter that's coming in. So that law has, there's always some exception, right? Like, where does a cell come from?
existing
And where did the first cell come from?
procreation.
From like
That's what I say when I teach bio.
from like objects.
Here. Well, I don't know what I had to say in public school.
Oh, I heard that.
Yes.
Jesus Christ.
In order to understand cycling, we have to understand systems because systems affect cycles somewhat. And these systems are called feedback loops. So when you kind of add something that can affect, adding something is input and the effect would be the output. And I think we have, input can come from the environment. Flow is what we reference as your throughput, so the process, and the output goes back out into the environment. So it comes into effect and gets within the cycle and then it goes out back into the environment. And I'm going to talk about the two different loops, and I'm sure you've heard of them in some other classes. These are going to be 2 questions on the AP exam for sure, possibly within an essay and in a multiple choice, always. Positive feedback loops, don't let the word positive fool you because it doesn't mean, and why am I yellow? It doesn't mean that it's something positive. It just means that whatever the change is going to cause the change in the same direction. So a positive feedback loop can be on a negative effect. That's what I'm trying to say. So positive feedback loop, whatever causes the change will make a cycle of it. That's what I'm trying to say. So for example, actually let's see if anybody can interpret this example for me. The one I'm trying to make bigger, this one. So go. That's a positive. That's good. You just missed the point of what, right? Because you haven't learned that. We have heat in the atmosphere on Earth. It causes ice to melt. When the ice melts, it releases what? When ice melts, what's released? Water vapor, which is the #1 heat-trapping gas. Even though it's supposed to condense and precipitate immediately, when UV rays hit it, it's supposed to re-radiate them back, and it just basically traps them. So you're supposed to have a re-radiation, and the water brings it right back down to Earth. And water vapor isn't the only thing in Arctic ice. What else is in there? Anybody know?
There's also the permafrost, so underneath there's decay.
You have ice in soil, and we're gonna learn about that, which is filled with soil. Is soil. It's filled with organic matter, and that organic matter will release heavy amounts of methane, which is another heat trapping gas. As a matter of fact, really in AP, the two main gases, greenhouse gases that you always take into consideration are carbon dioxide and methane. Nitrous oxide too. Nitrous oxide traps more than methane. And you have to learn all those and who traps more and what order and why and where they come from. So this is why the basic of cycling of matter is important, because when we cover the cycles of matter, we cover what affects these cycles or what contributes to excess amounts of the cycle, or it affects the flow of the cycle.
Okay, so at the beginning of the cycle, or like what?
Typically occurs when the system changes in another direction. And there's two, it's not, honestly, if you're gonna take the AP exam, you're gonna pick positive feedback loop as the answer. Because almost all environmental problems are positive feedback loops. Negative feedback loops usually involve like temperatures or your body systems.
So negative feedback would solve themselves, or
They don't solve themselves, but the change doesn't make the change continue to occur. So it kind of exits. It's like almost like a,
It like breaks it.
it breaks it.
And it can put it into another positive.
It can contribute to a whole other type of loop. So yes. And a thermostat is like a common example of a negative feedback loop. You turn down the temperature, and eventually what happens in your house? It'll get cold, and then what's gonna happen? It stops and it goes back up. So you see the changes in the opposite direction. All right, so matter. We're gonna cover matter through your ecosystem, and the same way your body tries to maintain homeostasis with its exterior environment. So the same thing that you studied in bio, those major elements of life, they're actually cycled. Yes, chomps. There, you said it. You remembered. Which are what, if you don't know?
Carbon, oxygen,
Correct. And I have them here, carbon. Oh, well, actually, what I have here is how they cycle. So we know carbon always is going to react with some oxygen or hydrogen, but we're going to study carbon cycling water, so the H and the O together, nitrogen, phosphorus, and sulfur. So there's no hydrogen cycle, there's a water cycle. Okay, so pause again. Look at it as high quality and low quality, because since you're seeing the transfers, you're going to see energy the same way, okay? And this is pretty easy. When you look at this overall picture, tell me the difference between high quality and low quality. Overall.
Like purity.
Purity.
Kind of like
Potential energy works.
like salt.
Density.
Like the difference between salt and the solution and water. You have water that's kind of like.
More concentration.
Correct. So like, if you look at solid, liquid, gas, what are you going to think of as high quality versus low quality?
More
What? Solid, of course, okay? Because if you look at these pictures, you're comparing almost all in somewhat states. Now, if you're talking about gas and then you're talking about automobile emissions, it's because it's being processed before it goes out, so it's going to be less
So
quality.
gas is less than hydrogen, which is less than salt.
Correct. Does that make sense?
don't they have more like delta G or something? Like they have.
Now, for each cycle, it's important that you understand that it's not a circle of life, okay? It's more like a web. Because just because I have to teach you the full circle, but there's no determining that it's going to be a perfect circle. It could go from the point that I start to the next point and back to the point that I started. Does that make sense? So I'm going to teach it to you as a full cycle, but it's not a full cycle. Even though it's called carbon cycle, it's just to show you all the ways carbon can go through the full ecosystem. And the full ecosystem involves what?
Inhabitants.
The biosphere, which involves
Organisms.
geosphere, atmosphere, hydrosphere, lithosphere is a geosphere,
Atmosphere.
and what? You name the layers and life.
Life.
Okay, remember biosphere is life in the layers. So you're gonna go through life in all those layers.
How could there be life?
Birds, us, I'm in the atmosphere.
Oh, okay.
Yeah? All right, so how does carbon, well, first of all, each one of the cycles, you have to know how they're mainly found, okay? What's their largest reserve? Or what's the compound that most is focused on in the cycle? So what do you think carbon is most cycled at? Carbon dioxide. CO2 is carbon dioxide. And you have to know everything I tell you verbally and its chemical compound. So carbon dioxide, CO2. How does carbon dioxide get into the atmosphere? Name me ways, and I don't think I have them all there, but when we breathe out. So I'm gonna put here, oops, that would be this one. Cellular respiration, but breathing out is same thing, and that's respiration. So I'll add it. What else? Biomass burn, what does that mean anyway?
Oh, like
Like burning trees and.
emissions.
Burning, make that word into a definition. Burning, what's mass?
Organic.
Organic
Matter.
matter. That's exactly what it is. If you need to write that down, write it down. Burning organic matter. Biomass is organic matter. What else produces carbon dioxide? We learned it in the birth of Earth.
Emissions.
Volcanoes. What else? We just talked about it 15 seconds ago, probably. Actually, it was probably more like 17 minutes ago, but what produces a lot of carbon dioxide to the point where we have to be concerned about the amount of carbon dioxide?
Cars.
Fossil fuel emissions.
Wouldn't that be
Good.
considered
And this is
biomass?
respiration. I don't know. Yeah, you're right. It would be, except it's not matter on Earth that we really are using. It's matter that we took out of Earth that fossilized and we brought it out and brought it into the cycle. So it's matter that was deep and buried that shouldn't have been taken out and brought into the cycle that was normally processing. Does that make sense?
Yeah, so does biomass burn like happen?
That too? So now that you said that, what does photosynthesis actually do?
Taking evaporated.
It takes it away from the atmosphere. So plants, through photosynthesis, are gonna take in all this carbon dioxide, so thank you plants, right? And what do they do for us? They provide oxygen. But in the carbon cycle, we're not gonna really worry about the oxygen, we're gonna worry about the, what's that? Glucose. Because if we're cycling carbon, we wanna focus on what part of carbon is being transferred. So C6H12O6 is glucose.
Oh, show it to
You have to know that.
Wait, this starts the what?
What does it start?
Show it to you guys.
If plants made sugar, what starts?
Oh, solar.
Energy cycle.
Which is what?
Oh, the Krebs cycle.
Cellular respiration.
Krebs cycle?
Glycolysis.
Yeah, it does, really. But for ecosystem transferring.
Oh.
Life cycle.
Because if cellular respiration started, then we would go right from plants back into the atmosphere. You see where I say it could automatically shift. Plants can take the glucose and use it for cellular respiration and release carbon dioxide as a byproduct. So the cycle can go right there.
Oh, yeah.
But if we're going to continue to go down, what's going to happen? You kind of said it. If you're transferring energy, what's that called? Because glucose is an energy molecule. How does eating?
Oh.
The food chain begins. Somebody's going to eat the plant. All right, I'm going to turn the page because it says to. Yes.